All right, in this video, we'll do one more example that uses double substitution. That means two different substitution. Let's do problem B here. So I'm looking for the integral of secant of log of x, tan of log of x over x square root of secant log of x. So there's a lot going on with this one. One thing I noticed though is I have log of x right here, and I have x in the denominator. So that tells me that I should probably take u to be log of x, and then when I look at my substitution, the du will take care of the extra x that was strangely hanging out in front. All right, so everything works quite well. I have the du, secant, and I have u inside, 10, and I have u inside. And my denominator is square root of secant of u. The new integral that I have is simpler than the old one, and it's written only in terms of u. So that was correct, that worked well, and it moved me closer to the answer. However, what I have now to integrate is still a complicated integral. It's not one of the basic integrals for which I have a formula. It's something where I'll have to do more work. I noticed that I can't really use algebra, but I noticed that I have secant inside the square root, and what I have above, that's the derivative of secant. So my next step is to redo another substitution. It doesn't matter what letter you use for your variable as long as you keep changing every time you do a substitution. So z is secant. dz will be the entire numerator in my integral. All right, so this will eat up all of that. So what I'll end up with is 1 over square root of z dz. Super nice. And I'll get z to the 1/2 over 1/2 plus c. And my integral is evaluated. The only thing I have left to do is go from z to u and then to x. So I have square root, 2 times square root. I had z, so that's secant of u. And so I get 2 square root of secant, and then u, I'm going to take log and plug it in instead of u. Don't forget your plus c. All right, so that's good. 2 different substitution. At each point, I took the obvious one and it got me closer to the answer. There is a shortcut though, and if you notice it, you might save a bit of time by taking it. What I see here is I have secant of log of x inside. So maybe I should just take secant of log of x. And if I take the derivative, I wonder if I have it. Well, that's going to give you secant log of x, tan log of x, and then the derivative of log of x, 1 over x dz. All right, so if you apply this substitution, you'll end up going directly to 1 over square root of z dz. And so you'll skip this substitution and just do a single one. Let me say, I still like this a lot. This is a bit of a Hail Mary. It's crazy that everything cancels and it's harder to see. I like being able to see right away that I'm taking the right substitution because I can see my du right there. Right, one more video about substitution. We'll need to prove the substitution formula, and then we'll be done with substitution. We'll move on to another technique.